So, if you've been following me, I've been covering black holes this class, and as it looks like, I'll keep doing so. So, for this project, I will be going over black holes again, basically the birth of one. So to start off, imagine a star so massive that when it dies, it doesn't just fade away, but it collapses into something so dense that not even light can escape. Now, if you've been following me, um, obviously, talked about this before, which would be a black hole. So basically, we're just gonna break down what black holes are, how they form, and why they matter to our understanding of the universe. So to me, black holes aren't just science fiction. They're they're real, and it's we've caught in a black hole before, the M85. Um, and they do play a huge role in shaping galaxies. In fact, there's a supermassive black hole at the center of our galaxy, the Milky Way. And understanding black holes, I'm sorry, helps scientists answer some of the biggest questions like how do galaxies evolve, what happens to matter under extreme gravity, and what are the limits of physics. Now, how does a black hole actually form? And it all starts with a massive star, much bigger than our sun, very much. So when that star runs out of fuel, it can no longer support itself against gravity. The core collapses inward, and this collapse triggers a massive explosion called a supernova, which I'm pretty sure you all know what it is. And if not, then you know pretty much the idea of a supernova. And what's left behind is the core. Compressed into an incredibly small space, gravity becomes so strong that it creates a boundary called the event horizon. Now, anything that crosses this boundary, matter, light, anything, literally anything, will be gone forever. At the very center is something called a singularity. That's the point where density becomes infinite and our current laws of physics break down. Now, you might be thinking, does this affect us here on Earth? Or you probably aren't thinking that because it hasn't. But just to give you guys a refresher, no, it does not. Not directly, at least. The nearest known black hole is thousands of light years away, so we're pretty much safe. But indirectly, black holes do impact everything. They control the motion of stars and galaxies, they influence galaxy formation, and even help scientists test theories like Einstein's general relativity. And without them, the universe would look very different. But why do these black holes form in the first place? And it all comes down to a balance between two forces. There's outward pressure from nuclear fusion and inward pull of gravity. So when this fusion stops, gravity wins. For massive stars, this collapse is unstoppable, leading to a black hole instead of a neutron star. So really, black holes are a natural result of how massive stars live and how they die. Now, the idea of black holes actually goes back centuries. In the 1700s, scientists first imagined objects so dense that light couldn't escape. But it wasn't until Albert Einstein developed the theory of general relativity in 1915 that black holes became scientifically possible. Later, physicists like Stephen Hawking expanded our understanding, even showing that black holes can slowly lose energy over time through something called Hawking radiation. And in 2019, scientists captured the first ever image of a black hole, confirming decades of theories, which is what I mentioned previously. So, what is next for the black hole research? Now, this black holes is something I've been wanting to research and trying to get into. And scientists are now studying how black holes merge, how they warp space and time, and whether they could help us understand dark matter or even other dimensions, which is something I also want to study once I graduate. There are still huge mysteries though, like what truly happens inside a singularity. Black holes aren't just the end of a star, they might be the key to unlocking the deepest secrets of the universe. So the next time you look up at the night sky, just remember somewhere out there, invisible giants are bending space, swallowing light, shaping the cosmos itself. And we're only just beginning to understand them. Thank you.